Hi, this is Alex from devstories.eu. High Performance Python Async, episode 15 of 17. You reach for a separate message broker like Redis the moment you need real-time events. But if your application already uses a database, you might be adding infrastructure complexity for absolutely no reason. PostgreSQL has a real-time message bus built right in. Today, we are talking about asynchronous listen and notify. Postgres supports a publish-subscribe pattern natively using two commands, listen and notify. The asyncpg library exposes this capability in Python through a method called addListener. Instead of writing a loop that pulls a database table every few seconds to check for new data, you register an asynchronous Python callback function on a specific named channel. When an event occurs inside Postgres, it broadcasts a message to that channel, and your Python callback executes immediately. Here is the key insight. A listener is not attached to your application globally, and it is not attached to a connection pool. It is bound to one specific individual database connection. This is a common point of failure. If you pull a connection from a pool, register your listener, and then release the connection back to the pool, the listener drops. To use this feature reliably, you must acquire a connection from asyncpg, call addListener on it, and holds that connection open indefinitely. It becomes a dedicated listening pipeline. Let us look at a practical scenario. You have a background worker that needs to wake up and process records whenever a new row is inserted into a jobs table. Instead of polling, you set up a database trigger. Whenever an insert occurs, the trigger executes a notify command on a channel called new jobs. It also sends a short text payload such as the unique identifier of the new row. In your Python code, you write an asynchronous callback function. This function expects to receive 4 arguments from asyncpg: the connection object, the Postgres process identifier, the channel name, and the text payload itself. Next, you acquire your dedicated connection. You call addListener on that connection, passing in the channel string, new jobs, along with your callback function. Finally, you keep the script running, typically by awaiting an asynchronous event that never sets. Your Python process now sits completely idle. It uses almost zero CPU resources and stops hammering the database with empty queries. The moment a transaction commits a new job row, Postgres pushes the notification over the open network socket. Asyncpg reads that socket and immediately schedules your callback on the Python event loop, handing it the new job identifier. The true power of this pattern is transactional consistency. If a database transaction rolls back, any notify commands executed during that transaction are automatically discarded by Postgres. This guarantees your Python workers will only ever wake up and react to data that has successfully been saved to the disk. That's all for this one. Thanks for listening and keep building.